Okay, so I was in the middle of the event part, and then I got disrupted or interrupted, not disrupted, but interrupted by my recorder. So now to continue with the occurrence of an event, we said that basically that's the event E. So we said that basically both of these you could call them an event based on the definition. Otherwise, you would normally call this a set, and I would normally call this an event, and I would call this some set, for example, related to that event, something like that. But based on that definition, you could call this an event, and you could call this again the same thing, event E, event E. So then based on that definition, you can say that the event E, which could be thought of as any of these two things, of a sample space S, is said to have occurred if the outcome omega of the experiment is such that omega belongs to the set E. So there is some outcome over here outcome omega of the experiment is basically if the outcome omega of the experiment is such that omega basically belongs to the set E. If the outcome omega is such that omega does not belong to the set E, we say that the event E has not occurred. So this is a simple thing, but basically probably stated not in the easiest way. So let me write this down. So we said that thus the event E of a sample space S is said to have occurred if the outcome omega of the experiment is such that omega belongs to the set E. Okay, and so then the rest of that is if the outcome omega is such that if the outcome omega is such that this is omega is such that omega does not belong to the set E, then we say that the event has not occurred. Then we say that the event has not occurred. So we have the next thing that we have here is types of events. Events can be classified into various types on the basis of the elements they have. So the next thing is types of events. Types of events. So then basically events can be classified into various types. Can be classified into various types depending on the basis of the elements they have. On the basis of the elements they have. Okay, so that is that. So one of the types of events is called an impossible and sure. Is basically, these are actually two types of events actually. Impossible and sure events. So you have impossible and sure events. So impossible and sure events are basically the empty set null and the sample set S describe events. In fact, null is called an impossible event, and S, that is the whole sample set, is called the sure event. Okay, so basically the empty set null and the sample set S, you can say that the empty set null and the sample space S and the sample space S describe events. The language is not very good here, but I suppose I cannot improve them, because I might add something to it, which is, I mean, it's not necessary really to add anything, but the language is not very good here. In fact, null is called an impossible event. So null, you can call it an impossible event. And S, the whole sample set, which is basically the whole sample set, is called a sure event. It's called the sure event. The sure event. Now, to understand these, let us consider the experiment of rolling a dice. The associated sample space is, so in the experiment of rolling a dice, the associated sample space S is equal to basically 1, 2, 3, 4, 5, and 6. So let E be the event the number appears on the dice is a multiple of 7. So let E be the event. So we have an event E, and which is basically the number appearing on the dice. The number appearing on the dice is a multiple of 7. Can you write the subset associated with the event E? So what we need to do is that to write the subset of the set S of S associated with the event E. That's what we want to do. And of course, the only number that we have here, which is a multiple of 7, is actually nothing. We have no 7 here, so you would get the null set. Clearly, no outcome satisfies the condition given in the event, that is, no element of the sample space ensures the occurrence of the event E. Thus we say that the empty set only correspond to the event E. So the only set corresponding to the event E is the empty set, which is, well, the null set. In other words, we can say that it is impossible to have a multiple of 7 on the upper face of the dice. Thus the event E is basically, thus we can say that the event E is equal to the null set. That's how they write it. E is equal to the null set is an impossible event. Is an impossible event. Now let us take up another event F. The number turns up is odd or even. Let's take another event F, which is basically the number turning up. The number turning up is either odd or even. And so of course every member of this set S is either odd or even. So then the subset corresponding to the event F would be the whole set S. So then clearly F is equal to, then you can say that F is equal to basically 1, 2, 3, 4, 5, and 6, which is equal to S. That is, all outcomes of the experiment ensure the occurrence of the event F. That is, all the outcomes of the experiment ensure the occurrence of the event F. Thus the event F is equal to S is a sure event. Thus the event F is equal to S is a sure event. And there is two more types of events, which is called a simple event and a compound event. And then we have a couple more things here to take care of. Okay, so there is another type of event which is called a simple event. Let's see what a simple event is. So a simple event is basically if an event E has only one sample point of a sample space, it is called a simple event. So if an event E has only one sample point, of a sample space, it is called a simple or elementary event. is called a simple or elementary event. Okay, so what that means is that, for example, if a sample space containing n distinct elements, there are basically exactly n simple events, and of course this is, I mean, in a sample space called containing n distinct elements, there are exactly n simple events. There are exactly n simple events, meaning that, for example, in the there is an example over here as well. For example, in the experiment of tossing two coins, in the experiment of tossing two coins, the sample space would be basically, for example, H, it would be HT, it would be TH, and it would be TT, right? So now there are 4 simple events corresponding to this sample space. 4 simple events corresponding to the sample space S. These are E1, for example, which is equal to, let's call it, for example, HH. Then you have E2, for example, another simple event, which is, for example, HT. There is another simple event, which is E3, for example, which is TH. And there is another simple event, which is, call it E4, which is the same thing as TT. And there is something else called a compound event. I need 443. Something else which is called a compound event. And what a compound event is, basically, so in a compound, if an event has more than one sample point, it is called a compound event. If an event has more than one sample point, it is called a compound event. It is called a compound event. For example, in the experiment of tossing a coin thrice, tossing a coin thrice, the events E, F, and G are all compound events. the events, I'll tell you about the definitions in just a few moments. The events E, F, and G are all compound events, where F is where E is equal to, where E is basically is the event exactly one had appeared, exactly one had appeared, exactly one had appeared. F would be at least one had appeared, at least one had appeared, and G would be basically at most one had appeared, at most one had appeared. Now, of course, that's not a very good example, because we don't have the sample space. But let's do the sample space here. So if you toss a coin thrice, you would get heads, tails, and heads, tails here, right? And so you could basically, taking these two together to find basically the three of them, taking these two together, you would get HH, you would get HT, you would get TH, and you would get TT. And putting these four with these two, you would get HHH, you would get HHH, you would get HHT, you would get HTH, you would get HTT, you would get THH, you would get THT, you would get TTH, and you would get TTT. So this is the sample space for this experiment, right? Now the sample space for this experiment, here we said that exactly one had appeared. So this is exactly one had appeared. So in this sample space, we have exactly one head would be basically this one here. It would be not this one, it would be this one here and this one here. So as you can see over here, we said that if an event has more than one sample point, it is called a compound event. More than one sample point, 1, 2, 3. So then you can call this a compound event. Or for example, at least one head appears. At least one head appears. You can find this, 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 and you can find this. So again, you can call more than one sample point. So you can call that a compound event. You can call that a compound event. Or suppose that you say that for example, at most one head appeared. At most one head would be, for example, this one or this one or this one. So again, this would be called a compound event. Okay. So then each of the above subsets So you can of course, the way that we showed them, you can write E, F, and G in form of sets, meaning that, for example, you can write E is equal to, for example, this set. We said exactly one had appeared, so exactly one had would be, for example, HTT, THT, and TTH. So HTT, THT, and TTH. And then F, you can write it as, for example, at least one had appeared, so that you could write HHH, you could write HHT, you could write, for example, HDH, you could write HTT, you could write THH, you could write THT, you could write TTH, and that's it, not this one. And G, you could write it in the form of a set as an event, of course. At most one had appeared. At most one had would be this one, this one, this one, and this one. So you would write, for example, HTH and HTT and THT and TTH, right? So then each of the above subsets, these subsets here, contain more than one sample point. Hence, they are all compound events. You call all of these compound events. Okay. Now, the next part that we have here is called the Algebra of Events, and so I think we will talk about that in the next video, because they are related to some other section really. So I'll see you in the next video.